Hey everyone, welcome back to today's lesson. So today we'll be studying the level by level traversal. Previously we have studied the inverter, pre-order and post-order using the recursion. But in today we will see another type of traversal that is level by level. So let's understand what's level by level traversal. This one. So first level by level, that means we'll be traversing in that manner. So first we'll be traversing the one. Then we'll be traversing the second level. So in terms of program, we call this zeroth level. Zeroth level. Then we'll be traversing the first level, that is 1, 2, 3, and then we'll be traversing the 4, 5. So this is called level by level traversal, and we got to understand. Now how will you be writing the code, that is. So first let's understand how we can think in terms of program. So first, this is the code. This is 1, that is 2, 3, 4, 5. So this is the pictorial representation that we see, but how it is actually represented in terms of program or in reality. So if you observe the real representation, so it is something like this. This is the node, and this is 1, this is 2, this is 3, and this is 4, and that's 5. So in those type of representation, so we our main motto is that we want to traverse like this. So in that type of traverse we can simply use a kiwi. So kiwi is that type of structure where we can insert from one side, and we can remove those elements from another side. So let's call one side as front and another side as the rear. So we can insert the elements from here. So if this is, so our key will be looking like this is just the structure, so it will be looking like this, the kiwi, that will be the kiwi, and this structure is something like this, and it is the kiwi. So what will we be doing now, that now we will be inserting, now we'll be inserting the elements into the queue one by one. Now notice, first we'll try to insert this one. So first when we insert one, so we inserted the one. Now we'll check from here, this one from both sides, left and right, that when we are visiting this one, if there are more elements in left and right side. So we clearly see that there is element 2 and there is element 3. So when we will be visiting this element 1, we'll be inserting that 2 and 3 also, 2 and 3. That is first time. Second, when we will be visiting this two, then we will again check if there is left and right. We see there is left and right, so we will again insert the 4 and 5, and we will process those elements one by one. So let's understand it one by one, every code line, and how we can write the code. So to implement this level order traversal that I made you understand here, this is level order traversal. So we will take that example, 1, 2, 3, 4, 5. Let's keep it 1 to 3, and now let's start understanding one by one. So first we will be thinking about the stopping case. Notice, when we stop iteration, when we encounter that the 4 when we encounter that 4, there is no left child or not right child, that means the left child and right child both are here null. That means a condition, if we encounter the null elements, then we'll simply stop. So we'll be starting writing our program by checking if the root is equals to null. So let's start writing. And for that, first, if we just understand from the scratch, first we have to create this binary tree node. So let's create the binary tree node by simply declaring. We'll be creating just this binary tree node. Okay, and this is called binary tree node. By what tree are represented? Binary tree node. So in Java, we can create binary tree node. We'll be in my video series. Now we are discussing only Java language. So we'll be creating like this: class binary tree node, class binary tree node. So now we are creating a custom data, this one. So this side is called the left, this one is called the right, and the middle one is called the data portion. We can call it value also. And now we'll just initialize integer data. The middle one is integer data because we always store integer portions here, either 4 or 5 or something else. So integer data. Now binary tree node, left and right. So we created the pointers. This pointer and this pointers are now created. And now we'll initialize this object. Now we'll just directly create the entire object. So for that we need to create a constructor, and constructor, let's create it, binary tree node. Right now we're creating a constructor, binary tree node. So whenever we will be creating this node, we will be passing an integer data. So we'll be taking integer data as the argument. And now we'll be creating the code. So to initialize, we have to write like this dot data by the new upcoming data. And this left and right, we'll initialize the left and right by null. Left equals to right equals to null. Once we have implemented this fraction of code, now we have created a binary tree node. Binary tree node by what we implement. And in this portion stores our data value. Data value. This person stores null. And that person also stores null. Okay. So now we have created this. Now our motto is to starting from here. Starting from here. And for that we have to create a binary tree class, because this entire event will occur in a class in Java file. So we'll be creating a binary tree class. Okay, then let's create a binary tree class from next below. Class binary tree. Class binary tree. Now we are creating the binary tree. The tree that we just saw above. This one. 1, 2, 3, 4, 5. So let me write once again the tree. Else we have forgot. 1, 2, 3, 4, 5. So now we'll be constructing the entire binary tree, and for that we will be writing this code. So we'll be starting from class binary tree. Now first we'll be initializing a root node. Why? Because the entire tree starts from this position, from this section, and this section, the first is pointed by the pointer called root. So first we'll be creating a root, and it will be binary tree node, binary tree node root. Okay, now we have created a binary tree node, that is the root. That means we have created a pointer. Now we have to create this tree also. Before we create the tree, first we'll be implementing the method. Or let's create the tree first. So how we can create the tree? So simply we can create the tree by using another method, just by using the constructor. Before we create the tree, we'll be first implementing the method of level traversal. So let's call a method. Let's create a method. Void tree traversal by level. So this method will be utilizing to traverse the tree one by one through the level. And for that we will simply implement this method without any argument type. So let's start this. First we'll be checking if, we'll be first checking the root condition, that is this condition. If this is the first one, we just initialize this root is like this, it doesn't point to anyone, it is just a pointer. It is just a pointer, it has no value. This root is having currently no value. So first we'll be checking if root equals to null. If root equals to null, and if initially the root equals to null, simply will return the program. So the program will stop from here. So that is the first condition. Second case might be that the tree might have a structure like this, because data name as a type, be binary tree node, because what we actually want to store, not one, this one will be inserted like this. We want to store entire node. This is the actual structure. So for that, kiwi binary tree node, kiwi, and that is equals to new linked list. So we are implementing this kiwi utilizing the linked list. Utilizing linked list, we are implementing this kiwi. So after we have created the kiwi, we have to add the root node. So let's add the root node. So we'll be just implementing to add the root node into here, into this kiwi. Now we have a empty kiwi. There is no elements. And we have to add elements from here 1 to here. That means first we have to add the root. So we will simply apply this line, that kiwi dot add root, or we can also apply kiwi dot offer root. Anything is all okay. So now we can see that we have added the root. After we have added the root, this one comes at here, that we are able to traverse this one from here. So now once this we have added in our QE, we have the entire tree. So we will start utilizing another tree, that if the queue is already full, we have to consider the cases also when we have inserted all the elements 1, 2, 3, etc. So we have to consider this case also. We have considered this one and now element has been inserted. Now we will be checking that if the queue is not full. So while queue dot is empty. So first we are checking if the queue dot is empty. That means if the queue is empty, it will return us true, and if not, then it will return us false. So we will running this queue loop till the queue is not empty. That means till the queue becomes again empty, like this. We'll be running this loop. So simply we'll be running. We just came up to the iteration method. Okay, let's or keep running. So now we'll be checking the first condition. We'll be pulling. Now we have inserted the one. Look, in the tree, our tree had, from tree we have inserted one here, and our tree was like this: 1, 2, 3, 4, 5. So after one, now we'll be pulling this data. So let's create another tree node, binary tree node. We can call it temp node or binary tree node current node. So binary tree node current node, that is equals to this QE, the name QE where we have stored the data, QE dot poll. So when we apply this function QE dot poll, the data is stored here. The data is stored here, comes back, and it comes to the current node. That means now the current node is having this data, this entire data, and one is stored here. So it is stored in current node. So from current node, now we'll be checking if this current node is having any data. That means now we'll be writing code like this: if current node dot left not equals to null. That means we'll be checking if the current node is not null. So if the current node is not null, then we'll be adding the data. So simply, and before we add the data, we need to process this data, because we have gotten this data and our main mode is to traverse. So we can, this time we can either add the data or we can print the data. Look, this time we have got the data in the current node. So now we can print the data or add the data. So let's print the data. So simply we'll be using the line system dot out dot println, system.out.println, and now current node is having all the values of it. So simply current node dot data will be accessing the data. So data will be printed one by one. So now we'll be checking if this section current node dot left not equals to null, but now current node dot left is not null. So what will we do? We'll be just inserting. We have visited the one, so one is crossed. Now we want to insert the elements of 2, 3. So we'll be just inserting 2 and we'll be just inserting 3. So again we'll be applying the function qe.add, and simply we'll be adding 2. I mean, we cannot call 2, so it will be root dot left, and again we'll be checking the second same condition, that if current node dot right, if current node dot right not equals to null. That means if the right is also null, that means if the right side is also having some data, it's having 3. So we're again adding the same function, kiwi.add root dot right. So okay, now we just added the 2 elements. So at the last we have we have checked all the things, q.add and q.write. So now our tree is constructed and it will work as per the program. So we'll be enclosing this all the things. So to check the entire things, now we have to create the binary tree also, and simply we can create the binary tree inside the public static void main function. So okay, we are writing this function also. So simply we'll be writing public static void main string args, and now we have to create object of binary tree class. So binary tree, and let's call the object as string. that is equals to new binary tree. So now we have created an object, and now first we will be creating initializing the root. So tree dot root. So what the root value has? New binary true node. So we'll be passing the first value here. We'll be passing this one. So one will be initialized. Okay, now we created the one. Now second, we have to create this also in the left section. So root dot left. We have to utilize the root dot left. So now we'll be writing root dot left. Sorry, we always have to write the tree because we are using the object of this class tree dot root dot left, that is equals to new binary tree node 2. Again we'll be utilizing in the right side, so tree dot root dot right. Now new binary tree node, and now we'll be keeping the 3. So now we have created a root node 1. Now we have created left 2, left 3. So let's again say that we want to create 4 in this left section and 5 in this section. So this is our root, this is left, and this is again left. So again we have to write that tree dot root dot left. So we'll be again writing like this. First we'll be writing tree because we are accessing this object tree, then dot root because we are starting from here dot root, then we'll come in the left section dot left, then we came the root dot left, and we want to insert this 4 in the left section, so dot left, that is equals to new binary tree node, and we inserted the 4 here. Now in the right section we want to insert tree dot root dot left dot right, tree dot root dot left and dot right. Now we'll be moving the right side dot right equals to new binary tree node, and this is. So now we have created the tree also. So if you want to traverse the tree, we have to just call the function from here. So tree dot traverse. We have to call this function that we created, tree traversal by level, and it will automatically traverse by level. So let's call this function tree dot traversal traverse by level, and simply now we can close the function and it will automatically work for all of our codes. So let's have a recap what we did actually. So it was very simple that what we did, we started from here. So it has become quite dirty, we cannot understand here. So I'm making you the recap. First we had a tree like this 1, and its actual structure is like this 1, and now in the left side it is having 2, 2, and in its right side it is having 3, and in its again left side it's having 4, 4, and its right side it's having 5. Okay, so you can understand 1 2 3 4 5. So what he did, that our core goal here is to traverse by level. First we'll be traversing the 0 level and we'll be putting 1. Second we'll be traversing the level 2 and 3, 2 and 3, and we'll be putting level 2 and 3, and third we'll be traversing the level 4, the last level 4 and 5. So what we did first, we just did like this. First we inserted these elements into the kiwi. So okay, this is our kiwi, and first at the first we just inserted root here. We inserted root element, so this was the root we inserted. So once we are traversing this root, that means once we have printed this root, now in the next step it has, if it has inserted through this, the root has come out through this. So in the next stage what happens, that when we print that element or add this element root, now we add this root dot left, we add this root dot left, and again we add this root dot right, and every time we keeps updating the data. So next time we add root dot left, so 2 and 3, so that way we keep adding. Next one again to each processed from this side, and 3 is remaining, so it becomes like this, the tree becomes like this. Now 2 is printed and there is 3. Now it is connected to root dot left, root dot right, so 4 and 5 comes here, and it again checks if there is any left tree or right tree, and it keeps printing the elements one by one. So we will have understood this one, the tree traversal by level. Let's look it in the code. So we will be implementing it in the coding section. Okay, just let me turn on the VS Code. Okay, now we are in the VS Code. So first we'll be creating a folder, mkdir, that is make directory, tree traversal, tree traversal by level, tree traversal by level YT. Okay, so we created the, and now we'll be entering into that directory. So command, we have to change the directory command. Okay, so now we'll be creating the file. What the file name will give, just a binary tree. So code binary tree dot java dot java. Okay, so we have created the binary tree. So first we have to create the binary tree node. So class first, what the data structure we have utilized here is we have utilized kiwi and we have utilized linked list. So we will be implementing those. Import java.util.kiwi. Okay, now we have implemented the kiwi, and now we'll be implementing the linked list also. Import java.util.linked. Okay, the Q will be capital Q because this is always capital. So okay, now we have implemented. Now we'll be creating the node. So class binary tree node, binary tree node. This is binary tree node, and it's having, it is the data part, left part, binary tree node left, right. And now we'll be just creating the constructor, integer data. Data is being passed, this dot data, data left. So okay, we have created the constructor by now, as you can see. So now we'll be creating the binary tree class, and then we'll be implementing the method. So now we'll be creating public class binary tree. Okay, and first we create the root node at the beginning of anything. So we'll be creating the root node, binary tree node root. So by now we have created the binary tree node, and now let's create the tree. So for creating the tree, public static void main string args. We always create the tree inside the main function of this. So now we'll be creating an object, binary tree new binary tree. Okay, now let's tree dot root equals to new binary tree node. So we are creating the new binary tree node with respect to data value 1, because first we had 1 in the root position. So this is the root. Okay, tree dot root dot left. Now we are inserting the left side, new binary tree node 2. In the right side, tree dot root. So in the right side we implemented. Okay, we implemented the right side. Now again we'll move into left and then right. Tree dot root dot left. So okay, now we have created all the tree that I've already saw on you. That you can see, now we have created this tree. First at the root position we have inserted this 1, then we have inserted 2, then we have inserted 3, then 4, and then 5. Simply the method I saw you here, that we have just written this fraction of code. Okay, so now we'll be implementing the rest of the coding section. So in the method, this is the root node. Okay, now void traverse tree by level. We're just providing it the name by level. So what is that in here? I'm just observing the name. So tree traversal by level, we have utilized the name tree traversal by level. So we can just write it tree traversal. Okay, it's anything, so we can give any name. So now we'll be start creating the function. So to create the function, first we will check the base case if the root is equals to null or not. So let's write this one, that if root is equals to null. First we'll be checking if root equals to null. If null, so we have nothing to work, we'll be just returning null. Second condition, will be initializing the key with respect to tree node. So kiwi binary tree node, kiwi new binary new linked list, because this is implemented with respect to linked list class. Now we'll be adding elements, kiwi.add root. Now root is added to that empty element. Now we'll be checking that if queue is full, queue.is empty, if empty. So till queue is not empty, we'll be keep working this tree node, binary tree node, and current node. Now we'll be popping the data, kiwi dot poll, because pop is not applicable here, kiwi.poll. So okay, now we'll be printing the root system.out.println, the data position, current node dot data. So we have printed. Now we'll be checking if current node dot left not equals to null. If that is not equals to null, that means there is some element, and we will be just adding that element in the kiwi. So kiwi dot add current node dot left. Again we'll be checking the second condition, that if there is element in the right side, if current node dot right not equals to null. If that is not equals to null, that means there is element. So kiwi dot add current node dot right. So okay, now we have implemented the kiwi and tree traversal one by one. So now we'll be compiling the file and we'll see if it works or not. So java compile -d dot binary tree dot java, and it got compiled. So java, so if you just run java binary tree, it just ran, but it didn't print because we haven't called the method. So now we'll be calling the method system.out.println, printing level by level. Okay, and now we'll be simply invoke tree dot traverse tree by level, traverse tree by level. Okay, now again we'll be saving and compiling the file java, and now you can see the tree program has printed the tree level by level 1 2 3 4 5. So okay, you can see in the console that we have the code has been worked. So next, in the next lesson, we'll be observing that how we can traverse the tree in order, pre-order, and post-order using the iterative method. Previously, we have observed the recursion method, but now we'll be observing the iterative because it is also useful for LeetCode questions and DSA algorithms. So meeting on the next lesson.